2-8. So this warm-up is very closely linked to what we are doing today.
Oh, similar figures.
Yes, similar figures. So really all you're doing today now is proportions, but in kind of a geometry way, in figures, in objects. So it's a little bit of geometry meets algebra here. Allie, did you have a question?
Is it supposed to be on the screen?
Yes, is it not up there?
I was wondering.
Thank you. And I'm already recording, so. I know. You guys, my class yesterday did that. I was talking about something that I thought was on the screen for like 3 minutes and nobody said anything.
Sometimes I don't know if they want it to be on the screen or something.
Yeah, but it was like, so like when you do this and I'm circling things.
If I seen that, then.
Anyway. Okay, so 2-8, the warm-up. It says a sailboat and an accurate model of the boat are shown. What is the length of the model sailboat? So if we're going to set up a proportion here, this is essentially what your lesson is today. So let's just see if you can set this up yourself. How would you set up a proportion right now?
The feet.
Let's say, here, I'm going to start you off. I'm going to put this 12 right here.
Oh, then I would do 4 feet on the other side, and then 9 under the 12, and then the X.
Is it 300? It's 12 over 9.
So you technically have options, but we typically like to set it up so that, I'm just going to drop you down here real fast. AB corresponds to FG. We make that our ratio, right? So what we're going to do here is we're going to say the 12 corresponds to what on our other figure? The 4. So 12 over 4 equals, and then you go back to the original figure, 9 over something. Call that your x, and you cross multiply. So 12x equals 36, and you divide by 12, and x equals, who said 3? Good job. 3 feet. Label it, okay? Yes. Total. That's the math you did. Yes, that's what the proportion does for you. But yes, that is what happens. That's fine, except for they're not usually that easy of a math problem. So that's why the proportion thing will always work. Okay, so that's what we're doing today is similar figures. Similar figures will have the same shape, but not necessarily the same what? Size. Not necessarily the same size. Okay, so same shape, but not necessarily the same size. This little symbol, the tilde, is similar to when tilde. You never heard of that before? Not Matilda, the tilde. This one is congruent to. So basically we're saying equal to when we use the congruence symbol. The similarity symbol means proportional, okay? So we're talking proportional for this one. Okay, so here's the setup. If they tell you that triangle ABC is similar to triangle FGH, then our angles are all congruent. This angle is the same as this angle. Angle A is the same as angle F. Angle C is the same as angle H, okay? The angles are equal in value, but the sides are proportional. So we can say AB, which is 8, over FG, which is 12, should be equal to AC, which is 10, over FH, which is 15, which should also be equal to what over what? BC and GH, so 12 over 18. Okay, and if you notice, when you reduce those fractions, 8 over 12 reduces to what?
4 over
2 over 3.
2 over 3. 10 over 15 reduces to? 2 over 3. And 12 over 18 reduces to 2 over 3, right? They are proportional because their ratios are all equal, okay? So that's similar figures, and that's what you're going to be doing today. But we're going to be using proportions to find missing pieces. Okay? So take a look at these two triangles. It says triangle ABC is similar to triangle DEF, and it matters the order they give it to you in. So A to B to C. That means A corresponds to D, right? It means B corresponds to E, and it means C corresponds to F. Okay, those pieces match up, which means the 10 corresponds to this unknown. I'm going to call it X. Okay, it means this AC corresponds to what? DF, the 18. Okay, I'm going to call that Y for now. So if you don't know a length, just give it a variable, and then you'll be able to set up a proportion. So what is the length of DE? So if I'm solving for this DE, I'll switch back to red. Okay, you already told me the 10 corresponds to that. So I can say 10 over X. Does anyone see the ratio I can set it equal to? It would have to be Y over 18, but then we have two variables, right? An X and a Y, so that would be hard to solve.
Should be 12
Close. 16 over 12. If I went bigger triangle to smaller triangle, then I have to go bigger to smaller again. 16 over 12. So you have to match up the corresponding pieces, okay? How do you solve that? You cross multiply, okay? Khalees.
Wait, okay, once we find X, then can we use that to figure out Y?
You can. You don't have to because you have your 12 over, you have these ones. So you can use that same, you can use this ratio to find your Y also if you want. But you could plug in what you found as long as you didn't round that answer. As long as it wasn't a decimal that you had to round. Okay? Okay, so cross multiply this. You get 120 equals 16x. And then divide by 16. What is it? 7.5? Yes. Okay. The second part says, what is AC? So what is your proportion to solve for Y? Y over what? 18. Y over 18 equals, and here's what Khalees was saying, could I drop my 7.5 in right here and say 10 over 7.5? You absolutely could, okay? The only reason I don't recommend doing that is what if you got the first one wrong? Now this one is going to be wrong because you're using the wrong number in the setup. So my recommendation would be go back to the other one and just use 16 over 12 where we have those numbers. No. Can you wait till after the lesson?
Yeah.
Can you?
Yeah.
Okay, then let's wait. So this one you cross multiply. 12y equals 16 times 8. 18 times 16, sorry. 16 times 18 is 288. And then divide by 12. Y equals, is that what you got, 24? I don't have it written down. Questions on that? So you have to go, like, your order matters, right? Big triangle to small triangle has to be big triangle, small triangle every time. Big to small, big to small, big to small. Could you go small to big equals small to big? You can, but you cannot go big to small equals small to big. Okay, you have to go in a consistent order. Khalees.
So how do we check our answer?
The thing you could do to check your answer is you could plug the number in here and then divide it. 10 divided by 7.5 should equal 16 divided by 12. It's not great because depending on how you set it up, if you do it wrong again, then it could still work out. But
So like we just have to repeat all right?
kind of. I mean, you can check your ratios at the end and make sure they're all the same ratio. Something over something equals something over something equals something over something.
How do you know it's right?
You would divide it, right? 10 over 7.5 has to equal 16 divided by 12 has to equal 24 divided by 18. So you can do each ratio as a division problem and make sure they're all the same number. And then you should be good, assuming you set up your problem right. Okay? Okay, take a look at this one. It says the sun's rays strike the building and the girl at the same angle, forming two similar triangles. So they're telling us these triangles are proportional. Okay, how tall is the building? So we're looking for X. How tall is that building? What proportion can you set up?
15 over 3
I did-
equals x over 5.
5
Okay.
over 3 equals x over.
Okay, so properties of proportions will get you the right answer there, but technically you're not setting it up the way that we're setting it up here. We want corresponding things as a ratio, right? So the height of the woman relates to the height of the building. So 5 over x equals what? 3 over 15. If I went smaller to bigger, then I have to go smaller to bigger. 3 over 15. Now, if you said 15 over 3 equals x over 5, you're fine, okay? Because you kept it consistent. So cross multiply that, you get 3x equals 75. Divide by 3. X is 25 what? Feet. Make sure you label it for what the problem is asking. Okay? Questions on that? Okay. Why don't you see if you can set this one up? Try to draw a picture to represent it. It says a 6-foot tall man is standing next to a flagpole. The shadow of the man is 3.5 feet. The shadow of the flagpole is 17.5 feet. So it's very similar to this, but acting like this is your flagpole, right? Very similar setup. See if you can draw a quick picture to help yourself visualize it, and then see what you get for your height of your flagpole. Because they're standing at the same angle from the sun. So the sun is like, I'm standing here, right? And the sun is behind me over there. So my shadow is going to be right here.
But why do we have to add that?
It's what helps you to see the similarity of the figure. Because it gives you congruent angles. And you'll learn in geometry that if you have two congruent angles in figures, then they are similar figures. So these would be proportional figures if their shadows are proportional and their height's proportional, which they would be in these triangles. What'd you get? 30 what?
30
Feet. Yes, 30 feet. Did you get 30 feet? Okay, so here's the idea. A man who is 6 feet tall has a shadow of 3.5 feet. A flagpole that is some number of feet tall. You can measure the shadow. You can't measure the flagpole as easily, right? So that's why we use this as a method, because now you can measure things that you actually can't measure if we know they're proportional. The sun is coming at the same angle, so these angles would be the same, and we know this is a right angle. So this is what we call AA similarity. You're getting a geometry lesson here that you're not supposed to be getting right now, but that's why this works. It's my cousin. So in this setup, then, if the shadow of the flagpole is 17.5, you can set up a proportion to find what the height of the flagpole is, because you're not going to measure, like, I'm not going to go out there and measure that flagpole, right? But I could measure its shadow with the sun very easily because it's on the ground. Does that make sense? That's the geometry behind it. Okay, so what's your proportion here? Let's start with 3.5. 3.5 over what? What's the corresponding piece? 17.5 equals, and now is it 6 over x or x over 6?
6 over
6 over x. Smaller to bigger has to equal smaller to bigger. Okay, cross multiply. 3.5x equals 105. And then divide by 3.5. And you get x equals 30. And don't forget to label it. We were talking feet, so 30 feet. Khalees.
I just, I don't know what I did there. I saw that.
Did you go 6 over 3.5 and x over 17.5? So properties of proportion says if you do that, you'll still get the right answer. So
Why do you have to do it with the corresponding if that property says?
So that's essentially what you're doing even when you do it the other way, right? You're going the small figure to the small figure equals the bigger figure to the bigger figure. So now it's this way and this way instead of this way and this way. But if you cross multiply that, you get the exact same problem. So that's why properties of proportions is beautiful, because you can mess up the setup and still get to the right answer because you still do have corresponding pieces in corresponding places. It's kind of lovely. So yeah, it's not wrong to do it that way. It's not as right to do it that way, but you'll get the same answer. So, okay, last little bit here. Scale drawings. Have any of you ever made like a model car, a model airplane, anything like that? They shrink the scale way down, okay, but it's all proportional to the actual object, the actual thing that you're making. So a scale drawing is similar, aka proportional, to the original. So if you've ever looked at floor plans for something or blueprints or a map, right? The actual thing, you can't just say, here's how to get to the mall. That would be a huge map. So they shrink it, but to scale. So proportionally, they shrink it down, right? And then you can view it on a map. So a scale model is a three-dimensional model similar to a three-dimensional object, which you'll see with our heart coming up in a little bit here. The scale is just the ratio of any length on like the shrunken version to the actual thing. So sometimes it actually doesn't go that way. Your actual might be the smaller thing and it gets blown up, right? If you think science class, what is something that's teeny and then you blow it up?
A bomb.
If you're, not like that. If you're looking through a microscope, right? Your object that you're actually working with is teeny, but you're making it bigger to scale, okay? Okay, so this is scale drawings. I'm gonna do 3 little things with you here. So here's what's important. On a map, they'll always tell you what your scale is, okay? So if you look here, it says 1 inch is 110 miles. So if that's my scale and I want to know the distance from Jacksonville to Orlando, Jacksonville's here, Orlando's here, how long is that? I think it's actually 1 oh no, you're right, it is 1 1/4. Is it 1 1/4? It sure is. It's 1 1/4. So that's, how do you write 1 1/4 as a decimal?
1.25.
1.25. So 1.25 inches. Why did I put that on top?
Because we put inches on top.
Because inches are on top over here. So inches have to correspond to inches. Miles, which we're trying to find, have to correspond to miles. How do we solve that? Cross multiply. So you're going to go x equals, and then you're just going to multiply these. 110 times 1.25, which I have to work out now because in my notes I called it 1.5. 137.5 miles. So that's the actual distance when on the map it was 1.25 inches. Okay, that's a scale drawing. This one says Jacksonville to Gainesville is 0.6 inches on the map. What is the actual? You're using the exact same scale, same map, same scale. So 1 inch to 110 miles. Where does this 0.6 inches go? On top is X number of miles. Okay, so again, cross multiply. X equals 110 times 0.6 is 66 miles. God bless you. Questions on that? Khalees.
When are we gonna be needing this in the real world?
I mean, if you do any sort of, I think that's my sub for tomorrow. Maybe not. I just saw her from the side. Does she drive that? She doesn't drive that. No. Just kidding. So, if you do any sort of like anything in a science field, for sure. If you do anything with architecture, you will absolutely use this. If you do anything with, like if you're a map maker, if you're a surveyor, there's lots of things. That is Lisa. That's your sub for tomorrow, you guys. Oh, she's bringing Kaylee a birthday treat. She's so sweet. So sweet. Okay, anyway. And here's the other thing. If you never use this again, did you benefit from it? Absolutely. Yes, because you had to be a reasonable, logical thinker, a problem solver.
We could use this as.
I mean, lots of things in the science field. Okay, listen. We'll do one more. We'll skip the last one. Here we go. 15. A giant model heart is shown below. The heart is the ideal, that's supposed to have an L, size for a person who is 170 feet tall. That would never happen. But they blow it. No, it does. They blow it up so they can investigate it deeper, right? No, this is. Listen to me. Listen. This is so actual. Because you could never have a 170-foot tall man, right? But if we do everything to scale, you could have this bigger version of a heart drawn to scale for you to look at, to study, to be a doctor who's going to do surgery on a heart. Okay, anyway, come back. It says, about what size would you expect the heart of a man who is 6 feet tall to be? Okay? So if the person is 170 feet tall and his heart is 14 feet, then where does our 6 foot tall man go, top or bottom? Across from the 170, the height of the man, across from the height of the man, the height of the heart, across from the height of the heart is what we're solving for, okay? So you cross multiply that, you get 170x equals 14 times 6 is 84, and then you divide, and you get x equals 0.49 feet. Now, can someone tell me a nice way to represent 0.49 feet? About what?
50.
About 6 inches, right? 0.49 feet is like half of a foot, 0.5, right? So you could say it's approximately 6 inches. Because we're converting. Half, right? 0.5 feet, a half of a foot is 6 inches.